Vectors in the plane, Part 2. If a vector v is written v1, v2, then recall that v travels a horizontal distance of v1 and a vertical distance of v2, and its magnitude is the square root of v1 squared plus v2 squared. Also recall that the vector pq can be written in component form. Suppose we'd like to add two vectors. If we have them written in component form, this becomes quite easy. I just add the horizontal and vertical components. Subtracting means subtracting the horizontal and vertical components. And I can also multiply by a scalar value by multiplying the horizontal and vertical component by that scalar value. Let u be -1, 2, and let v be 2, 3. Evaluate the magnitude of u plus v. First we find u plus v. U plus v is equal to 1, 5. And its magnitude is the square root of 26. Simplify 2u minus 3v. I find twice of u, I find 3 times v, and I subtract. Subtracting, I get -8, -5. A unit vector is a vector of length 1. If v equals v1, v2, then v divided by its magnitude will be a unit vector. It'll have length of 1 and it'll point in the direction of v. What is the unit vector of OP? I want a vector that points in the direction of OP but with a magnitude of 1. Recall that the magnitude of OP is equal to 5. So OP divided by its magnitude is a vector with the direction OP but a magnitude of 1. Two important unit vectors are the coordinate unit vectors I and j. Vector v with components v1, v2 can now be written as v1 times I plus v2 times j. So the vector OP can be written -3I plus 4j. The vector PQ that we saw in part 1 can be written 5I plus j. Assume the water in a river moves southwest at 4 miles per hour. If a motorboat is traveling due east at 15 miles per hour relative to the shore, determine the speed of the boat and its heading relative to the moving water. Let W represent the velocity of the water, V sub W represent the velocity of the boat relative to the water, and V sub G represent the velocity of the boat relative to the shore. So V sub W is the velocity of the boat relative to the water, while W is the velocity of the water, and V sub G is the velocity of the boat relative to the shore. Notice that the velocity of the boat relative to the shore is the combined velocity of the boat relative to the water plus the velocity of the water. We use a little geometry in the fact that we have a 45-degree angle to find the components of W. The motorboat is traveling due east 15 miles per hour relative to the shore. So that's just 15 comma 0. We will determine the speed of the boat and its heading relative to the moving water using the fact that V sub g equals V sub w plus w. We solve for V sub w. Solving for V sub w means I subtract V sub g minus w. So V sub w is equal to 15 plus 2 radical 2, comma 2 radical 2. Its magnitude, using the Pythagorean theorem, I get about 18 miles per hour. And the angle is the inverse tangent of the y component over the x component. A child pulls a wagon with a force of 20 pounds at an angle of 30 degrees to the horizontal. Find the force vector F. The horizontal component of F is just the magnitude of F times the cosine of the angle. The vertical component is just the magnitude of F times the sine of the angle. Since the angle is a 30-degree angle, cosine of 30 is just radical 3 over 2, and sine of 30 is just 1/2. And the force vector becomes relatively easy to find. I will see you in section 12.2.